Welcome to Calculus 1. Today we're going to talk about the derivatives of inverse functions. Alright, as you can recall, the inverse functions back in 1.9, what we so-called the inverse relation is the interchange between the x and y coordinates or x and y variable. Okay, that's the meaning of inverse relation. And I show you how to find the equation for the inverse function as well. I'm not quite going to do that again in this video, but I'm going to use the concept of the interchange between the x and y coordinate just in a minute. Alright, so continuity and differentiability of inverse functions. So if I have a function f whose domain is in an interval of I, okay, some sort of interval, if f has an inverse function, okay, that means f got to be 1 to 1, okay, like we talked about in 1.9. If f have an inverse function, then if f is continuous on its domain, then its inverse is also continuous on the domain, on its domain. If the function f is differentiable on an interval containing a number c, where f prime c does not equal to 0, or the derivative of the function does not equal to 0, then the f inverse is also differentiable at f of c. Alright. So the formulas for the derivative of an inverse function goes like this. Okay, so if f be a continuous function that is differentiable on an interval I, and let's say f has an inverse function that's called a g, then g is differentiable at any x for which f prime of g sub x cannot equal to 0. So my function g is the inverse function. So the inverse function, the derivative of the inverse function will be equal to 1 over my original function f, take a derivative of my inverse function. So in other words, I can rewrite it like this. Okay, if I want to find the derivative of my inverse function f, okay, it will equal to 1 over the composite function of my excuse me, my original function prime, or the derivative of the original function of my inverse function, f inverse. Okay, where my denominator cannot equal to 0. So if I want to find the derivative of my inverse function prime, I do not necessarily have to find my inverse function first, okay, from f. I can actually take a derivative of my original function, 1 over that, of my inverse that's inside of my original function. So that's how it goes. Let's see how it goes. Okay, alright, so here is x to the third minus 1. Okay, I want to use my function f in a given interval in a given real number a, and I want to find f inverse of a. Make sure my notation is correct here. I think it's inverse prime of a. Alright, sorry about that. This would be a derivative right here. Inverse prime of a. So check it out. What does this number a represent? This a represents this. If I would put this into the calculator, put this function into the calculator. Alright, this is what my cubic function looks like. Now I'm going to go to my table, okay, and see the 26 here is the y value. Alright, so the x value will be 3. So that means, well, my original function f of 3, I evaluate at 3, my y value is 26. So, knowing that inverse function is this interchange between the x and y coordinates, that means my f inverse of 26 will equal to 3. Okay, just the interchange between the x and y variable. Alright, so since inside my formula here has a f prime, so we'll go ahead and take a derivative of my function f. Alright, use the power rule. That will give me 3x squared. Alright, so this is my f prime. So to find my f inverse prime, the derivative of my inverse function, whatever that is, it will actually equal to 1 over my original function f prime of my f inverse of 26. In this part, okay, this part is turned out to be a 3. That will be from right here, knowing the interchange between the x and y variable. Alright, so with my inverse function, when x equal to 26, for my inverse function, the y value will be 3. So that will be 1 over f prime of 3. And that will be 1 over, well, evaluate 3 at f prime. So I will substitute my 3 into for my x. So that will be 3 times 3 squared. 3 squared is 9. 9 times 3 is 27. So that will be 1 over 27. Okay, and that will be my answer. Alright, so this A is really used for the inverse part. So if I want to find the derivative of my inverse, f inverse of 26, that's what this whole problem is actually wanting us to find. And to find it, okay, we first got to know, okay, the interchange between the x and y variable. So we know what's f inverse of 26 equal to, which is 3, because I'm actually using it in the part inside of my composite function with my f prime. Alright, let's try another one. And this example here will kind of lead us to the inverse trigonometric functions. So I'm gonna let my function f to be tangent x in the domain of negative pi over 2 to pi over 2. Alright, inverse of tangent is called arctan. Alright, so, and I write a note here, f prime of x is equal to secant squared x. Okay, as you can recall, derivative of the tangent, okay, is going to be secant squared x. So using that formula I have earlier, alright, the inverse function prime is normally equal to 1 over the original function f prime of the inverse. So that will be 1 over f prime. I'm going to write down what my inverse function is inside this big old parenthesis. My inverse function of tangent is arctan of x. So that would be arc tan of x. Alright. And my f prime is secant squared x. And secant squared x, according to the trig identities, secant squared x is also equal to tangent squared x plus 1. So I'm going to use the fact that secant squared x equal to tangent squared x plus 1. So my f prime is tangent squared x, and my x part x part right here, I'm going to put my arctan. Okay. That will be tangent of the arctan of x. Everybody got to be squared because the tangent squared, and then plus 1. Alright, so since tangent and arctan are inverse to each other, so they can kind of like cancel each other out. So that means the only thing I got left is just this x got to be squared, then plus 1. There you go. So that means if I want to take a derivative, okay, of the inverse, which is the arctan, it will eventually become 1 over x squared plus 1. So if you look at object number 2, the derivative of the inverse trig function, okay, derivative of arctan of u will be 1 over 1 plus u squared times whatever this u is primed. Okay. Derivative of the arc sine and arc cosine, okay, they look just alike. 1 over square root of 1 minus u squared times u prime. It just, the cosine has a negative sign to it. Derivative of arc sine is a positive. So that's why I put them side by side. You can see the one on the right side has a negative sign, the one on the left don't. Alright, so let's give this a try, okay? This is real simple. We just got to follow the formulas here. Alright, derivative of arc sine to 3x. So the 3x is like my u. So derivative of arc sine is 1 over square root of 1 minus u squared. So that will be 1 minus my u, 3x, got to be squared, times u prime. If I take the derivative of my u, that would just be a 3. So my answer would just be 3 over square root of 1 minus 9x squared. Okay, 3x, whole thing squared, 9x squared. Alright, let's do one with the arctan of 2x squared. Alright, so again, my u, I'm going to let my u to be 2x squared. So arctan of u is 1 over 1 plus u squared times u prime. 1 over 1 plus u squared. My u, 2x squared, will be squared, times my u prime. My u prime will be 4x. Alright, if I simplify this is going to be 1 over 1 plus 4x squared. Okay, and the 4x times the 1 on top will actually make it 4x over 1 plus 4x squared. Okay, not too bad. And I did not mean to write x over here. This is actually absolute value of u. I did not mean to put an x right there. It's supposed to be u. Alright, let's do a secant. E to the 3x. Arc secant e to the 3x. So my u is e to the 3x. Alright. So the arc secant of u is 1 over absolute value of u. Okay, it will still be positive, so I will just write e to the 3x. Absolute value e to the 3x will still be positive. So I'm not going to put my absolute value on. Times square root of u squared e to the 3x squared minus 1 Alright, and I believe arc secant is going to be a negative answer. Oh, excuse me, arc. Arc secant is positive. I think I wrote it down wrong here. I got secant on both sides. I did not mean to have arc secant on both sides. Let's see what the formula should. I copied it down wrong off the formula sheet. Arc secant is positive. Cosecant is negative. So this got to be cosecant. Sorry about that. I just realized this would be cosecant. Arc cosecant is negative. Alright. So 1 over attribute of u times square root of u squared minus 1 times u prime. So e to the 3x, since I got this up. Alright, e to the 3x. My u got to be the 3x. So that will be e to the u times u prime. So when I take a derivative of my 3x, that would just be 3. So that would be 3 times e to the 3x. E to the u times u prime. Alright, if I simplify this, I believe e to the 3x can be cancelled out, top and bottom. So that'll leave me with the 3 on top over square root of, using power rule here, I multiply my exponent, so that'll be e to the 6x and then minus 1. Alright, so just give a couple of examples on how we do derivative of inverse trigonometric functions. Okay, so I just want to show you this part of the formula sheet, and I apologize, I made a couple of mistakes here when I type it out. Alright, that will be all for this lecture video. Thank you for watching.